So, good day, sir. For today, our topic is the resistive forces low speed case. So, according sa video, um, let's imagine we have an object, that is falling in a gravitational field. So we have a gravitational force, of course, and this object is like a marble nga nahulog in a vat of oil, and naa siya'y velocity dependent resistive force that is acting sa kanang object. And again, let's choose the positive side, which is direction, or the direction down. And now, ang kanang object, or for the objects that are moving very slowly in a fluid, let's make a model for our velocity dependent resistive. We will assume that the resistive tone is proportional to the velocity, or kanang nag-oppose siya sa direction of motion. And we'll put a coefficient alpha. Oh, by the way, magputang taog negative. And we'll put a coefficient alpha in front. Ito ba na is, it will become this. Mura siya x. Then x. Meron ka tong. And then, this is our model for velocity. Dependent resistive forces for objects that are moving very slowly. For our case, let's consider the units of the coefficient alpha. So the unit of alpha, which is the have the unit of force divided by velocity. Unit of force divided by velocity. And that gives us a kilogram per meter per second squared, divided by the unit of velocity per second. And so we see that per second, then so you see that coefficient of alpha has the units of kilogram per inverse second. Then, karon is atong i-apply ang Newton's second law. Ato'y analyze ang forces and get the equation of motion. F for this object falling in a viscous medium with a resistive force. And the J hat, and J hat direction, we have a gravitational force, and we have a resistive friction force. And that's equal to Vy over dt. Notice that the acceleration we're not treating as a constant though, no. It's a derivative of the velocity. Let's rewrite this sa katong video gud kay gi-rewrite sa man, and it will become like this. Over dt is equals to g, and then x over m v y, or the g minus alpha or mvy. Now, this is a linear equation. Ang linear equation, so may siyang linear velocity first order, and then this is differential equation. And with a constant term in here, constant term, muna siya ang kanang g, which is called an homogeneous linear first order differential equation. And then, let's separate the variables. And parehas sa itong una, ito i-separate ang variables. So what we do is bring the velocity terms. So before nato siya integrate, need na to i-rewrite usan siya. Ang mahitabo na is d vy over d vy over g minus s alpha vy is equals to dt. And now mag-integrate na ta. Para to saan siyang i-write diri dvy minus mg over alpha plus dt. So let's start integrate. Mag-first tawag integrate diri a. So now let's first integrate the sides. So vy all equals 0 and this side, and vy of t in the upper over here. And let's call our integration a variable t prime. Dili na po ito because we will integrate t prime to 0 and sometime t to the ibaw. So this is our variable, and the velocity is a function of time. So now, during this interval, first of this constant term comes out, so we have 1 over alpha minus alpha over m. And the interval is just a natural log integral. Ano na siya? Vy minus mg over x, then over minus mg over alpha na siya, alpha equals t. Now we can rewrite this equation by bringing the m over the alpha to the other side. So mahitabonan niya is yun siyang vy minus mg over x over over negative mg over x equals m I negative or minus alpha m t. Now recall that e to the log of any quantity x is equals to x. So the last part, it is will become like this now.